This is Mr. Wright. We are going to talk about parallel and perpendicular lines. So if you look at these two lines, what you'll notice is that the slope for both lines, it goes up 2 over 1, up 2 over 1. So these two lines are going to be parallel. So the big takeaway here is that parallel lines are going to have the same slope. So if they have the same slope, they're never going to cross each other in a coordinate plane. So if I want to see if they're parallel, we're just going to check the slope. So when we're doing slope, I always start at the left-hand point. I go up or down first. So with both of these, I see that they're negative, but let's see if their two slopes are going to be the same. So for n, I go down 2, and then over 1, 2, 3, 4, 5, 6, 7, 8. So the slope of n is negative 2 over 8. The slope of k is I go down 2 over 1, 2, 3, 4, 5, 6, negative 2 over 6. You want to simplify these just to make sure that it's not the same number. Negative 2 over 8 simplifies to negative 1 over 4. Negative 2 over 6 simplifies to negative 1 over 3. So those are not parallel because it's not the same slope. I look at Q and M and find these slopes. This one, if I go from these 2 points, it goes up 1, 2, 3, 4 over 1, 2. So I could say it's 4 over 2 for Q. For M, if I go from point to point, it goes up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 6 over 3. If I simplify these, I get 2 and 2. So because lines Q and M both have the same slope, those two lines are going to be parallel. You can try these on your paper. So you just look at each set, see if they have the same slope or not. If they have the same slope, they would be parallel. If they don't have the same slope, they're not parallel. Next one we're going to look at is perpendicular lines. So we know from earlier in this unit that perpendicular lines, they cross at like a 90-degree angle. All right. So if I look at these two examples, line 1 has a slope of negative 1 over 2, so it goes down 1 over 2. Line 2 has a slope of 2 over 1, so it goes up 2 over 1. So the relationship to get from one to the other, we say that the slope of perpendicular lines, the slopes are opposite reciprocals. So the slope of perpendicular lines are opposite reciprocals. So just to go back to the other page, the way that works is they're opposites, meaning that one is negative, the other one's positive. It doesn't matter. They just have to be one's positive, one's negative. Then they're reciprocals, which means that their flat fraction is flipped. So 1 over 2 to 2 over 1. So let's just come up with some more examples of opposite reciprocals. So if I started out with 3 over 4, the perpendicular slope would be negative 4 over 3. Those would be opposite reciprocals. If I start with negative 7 over 2, the opposite reciprocal would be positive 2 over 7. So it changes from either positive to negative or negative to positive. It gets a little tricky if you have like a whole number. Let's say I had 5. The opposite reciprocal of 5, so I know it's going to turn to a negative, but you kind of want to think of this as a like a fraction. So if there's no denominator, I could say this is the same as 5 over 1. So the opposite reciprocal would be negative 1 over 5. So whenever you have just like a whole number, the reciprocal is going to be like 1 over that number. So just one more example, if I had like negative 1 over 8, the opposite of reciprocal of that would just be positive 8 over 1, or just 8. So that is how opposite reciprocals work. So if two lines, if their slopes are opposite reciprocals, they would be perpendicular. So let's look at an example. Let's do lines K, let's see, J and K, let's see if those work. So line J goes from this point to this point. So that would be down 1, 2, 3 over 2. So line J is negative 3 over 2. Line K goes from this point to this point. It goes up 1, 2 over 1, 2, 3. So it goes up 2 over 3. So when I look at those, now I'm going to just ask myself, are those two numbers opposite reciprocals? Are they opposite signs? Yes. Are they reciprocals, which means are they flipped? Yes. So lines J and K, are they perpendicular? Yes, they're perpendicular. So that's how you find perpendicular slopes from a graph. So just a couple more examples, parallel versus perpendicular. So perpendicular would be opposite reciprocals. So the opposite reciprocal of negative 3 over 5 would be positive 5 over 3. The opposite reciprocal of 2 would be negative 1 over 2. The opposite reciprocal of 1 over 7 would be negative 7 over 1. Let's look at one more thing. So with equations, these equations, most of these are in slope-intercept form. The slope is always going to be the number next to the x when it's in slope-intercept form. So when it's y equals, it's the number next to the x. So my slope is going to be, for like this first example, would be 5. So a parallel slope, parallel lines have the same slope. So the slope would stay the same. But with perpendicular slopes, the slopes are going to be opposite reciprocals. So the opposite reciprocal of 5 would be negative 1 over 5. So you want to do the same thing for 2 through 4. But then when you get to 5, if you guys notice, it's not y equals anymore. So in order to figure out the slope, it has to be y equals, like the rest of these are y equals. So we got to get the y by itself. So the way that we would do that is first you want to move the x to the other side of the equation. So I get 3y equals 24 minus 2x. Then you divide, you got to get the y by itself, so you divide everything by 3. So I'm left with y equals 24 divided by 3 is 8. And I just leave this as a fraction, minus 3x. So my slope is negative 2 over 3. So we don't know that until we get it to set be y equals. So the parallel slope stays the same. The perpendicular slope would be the opposite reciprocal, so I flip it and it becomes positive. That is how parallel and perpendicular lines work.